This video, we are going to do these 7 questions from the chapter probability. And the key concepts used over here, I can see that the concepts of combinations will be used here, that is different selections and permutations used in these questions, right? And the other concepts used here will be uh, probability of A naught is 1 minus probability of A that is happening an event. So let's begin with solving one by one. In this question, it says out of 100 students, two sections, that is, section of 40 and 60, are formed. If you and your friend are among 100 students, what is the probability that you both enter the same section, you both enter the different section? So that means it's a case of selecting students from given number of students. So let's say if I say this is section A and this is the other section, that is section B. Section A has how many students? Capacities. There are 40 students are there in this and some 60 students over here. Now, question in the first part. First of all, we will look for selecting two students from 100. So you know that what you should say, that total number of ways of selecting two students from 100 student is what? 100 C2. 100 C2 is the, this is the total number of ways of selecting two students from 100 student. Now possibilities that both are in section A, or say the section comprising 40 students, is only possible when out of these 40 students, two students are selected such that two of them are you and your friend, right? And the second is that out of the 60 students in the other section, right, two of them are the friends only. So we can say that the total probability, like we are doing the case one over here, both entering the same section. Same section means either section A or the first section or the second section. So we can say that the required probability will be 40C2 plus, this is or, right? That's the reason plus, it's not and, that divided by 100 C2. That will be the required probability. Let's say if I mark it by PA. Right, now comes the calculation. So this is 40 C2 is what? 40 factorial, that divided by 40 minus 2, that is 38 factorial into 2, plus this is 60 factorial divided by 60 minus 2 is what? 58 factorial into 2 factorial over we have 100 factorial divided by 100 minus 2 is 98 factorial, that multiplied by 2 factorial. So I can see 2 factorial gets cancelled everywhere. These 2 factorial I can cancel with the denominator. So now we have calculation as what? 40 factorial can be written as 40 into 39. That multiplied by 38 factorial will get cancelled. On the other side, it is what? 60 into 59, and 58 factorial will get cancelled. So in the below, it's 100 into 99. Well, this is something we have to calculate. So 39, we can take common, but I think it's better to multiply. So we'll simply multiply 39 into 4. That comes out to be 156. So it should be 1560. And similarly, if I multiply 59 with 6 only, it should give you 3540. And this is what? 990. Right. So we'll be adding this. When adding 156 with this 500, so it results to give you 5. Okay, how come the probability? Yeah, there is 20. Yeah, this is 5100, that divided by 9900. This get cancelled. So we can reduce it, right? So divisible by what? 3. 317 times and 333 times. So we got 17 over 33. Right? The answer for this is 17 over 33. Now in the next part, what we have to find out, they both enter the same section. So what we can say that both entering the same section will be calculated as 1 minus, right? Entering different section, right? Different section, entering. Okay, we have to find a different section, sorry, right? I took it opposite. So we have both entering the different section we have to find out. So we can say that it is 1 minus entering the same section, right? 1 minus entering the same section. That is for this B part, right? So it should be 1 minus, what was the value? Yeah, 17 over 33. 17 over 33. 33 minus 17 should be how much? 16. Yeah, should be 16 over 33. So this will be the answer for the second part, that is 16 over 33. Now in this question it says a die has two faces, each with number 1 in 3 faces, and number 2 on one face with number 3. Wait. Let me read it again. I got confused. A die has two faces, each with marked 1. So two faces are marked 1. Let me write it down. So 1 is marked in two faces, right? And there are 3 faces, each with number 2. So 3 faces, each with number 2. That means there are 3 faces, each with number 2, right? And there is one face with number 3 on it. Yeah, that's what. Now, if I read it further, it says if a die is rolled once, determine the P2 here means the probability of the on a single throw you are getting 2. So clearly there are 3 such faces. So favorable is 3 and the total is 6. So the required probability will be 3 over 6, right? So that is half is the answer in this case, 3 divided by 2. Now if I read the next one, the second part, probability of getting 1 or 3, either 1 or 3. So we can say that probability of getting 1 or 3 will be what? Right, there are 3 faces again, right? For favorable and total is 6. So again it is half, right? And not getting 3, that means it should not be 3. So that means remaining 5. So P not 3 should come as what? 5 out of 6. Right. That way we can do. As 5 by 6 is not cannot be reduced. So we'll say this is the answer. In this question, it says in a certain lottery, there are 10,000 tickets sold and 10 equal prizes are awarded. What is the probability of not getting a prize if you buy 1 tickets, 2 tickets, and 10 tickets? So we can see that we have together 10,000 tickets and only 10 tickets have prizes. So we can say that out the one which does not having price is what we have to get. So that means out of this 10,000, only 10 tickets have price. So the remaining should be what? 9,990 does not have a price. Now in the first part, what we have to find, the not getting a price when you buy 1 ticket. So the total possible ways of buying 2 tickets not getting a price. So that means it has to among these 9990. That means total possible combinations or selection of 2 tickets from this much ticket is 9990 C2, that divided we are doing for case 1 when you are buying 1 tickets, right? Not 2 tickets. So it has to be 1. And total possible ways of selecting 1 ticket from 10,000 tickets is this. So let's say if I take this as probability of case 1 PA, that results to give you how much? This is 9990 only, that divided by 10,000. So it can be reduced. Now if I take the other case, that is I took the second case as PB. Here you are buying 2 tickets and you are not getting a price. That means you are buying these 2 tickets from these 9,990. So buying 2 tickets from 9,990 tickets are this, and similarly buying 2 tickets from 10,000 tickets is this. So this will be the required probability you can calculate. Now we have one more case, buying 10 tickets. So the same way you are buying 10 tickets from these non-price containing tickets, and the total ways of buying 2 tickets from 10,000 should be 10,000 C2. This way we will get the answer for this. Now in this question it says a box contains 10 red marbles, 20 blue marbles and 30 green marbles, and 5 marbles are drawn from the box. What is the probability that all marbles are blue? Second case, at least one will be green. So we have how many marbles? 10 red, 20 blue, 30 green. So that means 60 marbles. And we have to take out 5 marbles. So if I ask you what are the total ways of taking out 5 marbles from 60 marble is what? 60C5, taking out 5 such marbles, total possible ways. It is 60C5. That means taking out 5 marbles from 60 marbles. Now, if I say what is the first part, it says all will be blue. So how many of them are blue? You can see that 20 of them are blue. From 20, taking out 5 marbles. So possible ways of taking out 5 marbles from 20 marble is 20C5. That should be the first part. Now, in the next part, the question here is at least one of them is green. So whenever it's a case of at least, what do we write? We write at least one of them is green is 1 minus none of them is green. So if I place 1 minus, what is the probability that none of them is green will be, that means if none of them is green, it means all these 5 marbles, one more time, it should not be green, right? It should not be green. That means it can be either red or blue. Irrespective how many red, how many blue, doesn't make difference. So we can say that none of them is green should be what? So the remaining 30, here 30 I mean this 30, right? Together. From the remaining 30 marbles, we have to take 5 marbles. And the total possible ways remain same. Out of the 60 marbles, we are going to get 5 marbles. So the required probability will be this for the second part. Let's say if I use PB for the second part. So PB is this. In this question, it says 4 cards are drawn. So total of cards are 4, and that's from the well shuffled deck of 52 cards. What is the probability of obtaining 3 diamonds and 1 spade? So we have to take out 4 cards out of 52 cards, out of which 3 of them are diamonds and 1 of them are spades. So what we know, how many diamonds are there? 13 diamonds are there, and spades are also 13. So we can see that from these 13 diamonds, we need to take out the number of ways of taking out 3 diamonds from 13 diamond is this. And you see we have an and, so we'll put a multiply 13C1. And then we have to take out altogether 4 cards, right? So the total possible ways of taking out 4 cards from 52 cards is this. Rest is the working that involves using factorial to calculate it. Now moving to the next. Now, in this question, it says on her vacation, Veena visited 3 cities. These are A, B, C, D in random order. What is the probability that she visits A before B and with so many subparts? Now, first of all, you should know that visiting 4 cities, right? We have 4 factorial ways by these cities can be visited. So that is 24. So number of sample point is easy to get, but then you know that it is order in which these cities are visited are important. That's why I've made a table like this. So it's always good to obtain a table vertically rather than writing them randomly. So in such a case, what you can do, like you can fix 2 letters, say AB I fixed, therefore the last 2 letter can be either CD or can be DC, right? So that here I have fixed A and B at the first place. Now fixing AB at the first 2 places, we are left with two selection, two arrangement which we have done. And next I'm going to pair AC in the first 2 places like A and C. Then the 2 possibilities are what? It can be BD or it can be DB, right? Keep remaining A and C at the first 2 places. AC got exhausted, then the next combination will be AD. With AD, what you can do? You can write BC or can be CB. So this is AD only. Now finally, AD got also exhausted. Now keep B at the first place, right? Keeping B at the first place, and A later, right? So we started with A in the first place, got exhausted. Now I'm keeping B at the first place. So it can be BA. The other letters could be CD or it can be DC. And as I said, yeah, I have fixed B at its first place. Now, keeping B at its first place, now make a pair of BC. So it can be either AD or it can be DA, right? Keeping BC in this manner only. And now B with paired with C. Now I'm going to pair B with, where's B? Yeah, B with D. So pairing B with D, it could be AC or it could be CA. Continue to pair BD. So BA got exhausted, BC got exhausted, BD got exhausted. So I can see that B got exhausted and its first place. Now it's turn for C. Now I'll begin with CA. So other two letters can be what? Right, it's something like dictionary. Okay. So if I fix C on its first two places, it can be either B, D, or could be D, B. Let CA be at its first place, first two places. Now with C pairing with B, CB, not only just pairing, order C and B. And then it could be A, D, or it could be D and A, right? It can be D or A with C and B at first two places, first and second places. CA got exhausted, CB got exhausted, and then we are left with what other? CD, right? C and D. Let me write C and D twice. So it can be either A, B, or could be B, A. Could be B, A. Okay, we have done CD. Okay, now next is what? Keeping D. So that means D at its first place. So let's begin with the same way. DA, if I place DA in the first two places, DA. So what is the possibilities? The other two letters can be either BA, BC, right? BC, or it could be CB. Now more cases are there. How many of them are? Let me just check it. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So I need one more. Let's say if I place one over here, it can be visible on the screen. Yeah, we are doing DA and DA got exhausted. Then with D, what we can say? With D, we have D paired with A. Now I'm pairing D with C, D being first place. So it can be A, B, or D in its first place, C in the second place. It could be AB is done, then it should be BA. DA pairing is done, DC pairing is done, and then it should be DB pairing, D, and then D paired with B, and then the other two letters will be what? C and A, or D paired with B again. It could be A and C. I think we have done 24 of them. Right. Even we can cross check that each in its first place is coming how many times? 6 times. So 1, 2, 3, 4, 5, 6. Yes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes. 6 into 4, 24. This is done. Now what we have to find out, we can say that A before B. So you can just find out. Once you make the table, you can do on your own. Right. So A before B is what? A before B is this line. Here is also A before B, A before B, A before B, A before B. Has to be because A is the first place and this cannot be. This whole thing cannot be because B is appearing before. Now A before B, I can say this is also A before B. This is not, the next is not B before A. We need A before B. And A before B is this also, A before B is this also, A before B, not B before A, and right. This is also not true, right? B before A A before B. Okay, so we can see how many cases we need to count it. That is 6 for this, 7, 8, 9, 10, 11, 12. So n of, if I say for the first part, how many was there? 6, 7, 8, 9, 10, 11, 12. So it's 12 out of 24, that is halfways. Now, if I read the second part, it says B before A before B and B before C. A before A before B. Okay, let it be like this only. A before B, we have already found. Now, what we are going to do, we need to highlight in those B before C. So check here. B is before C here. B is before C. That's true. This is also B before C, but this is next is not correct. Next is not B before C. Third is B is not before C. This is not B before C. This has B before C, B before C. The next is C before B. And third is what? Yeah, it does not have B before right. So just eliminate those where B is not before C. Just eliminate those. So B is not before C over here. B is not before C is over here, right? So we can say that there are 1, 2, 3, 4. So therefore we can say that the probability, this is not n, sorry. The probability for the next case is going to be how much? 4 over 24. That results to give you 1 over 6. Right. Let me see. Similarly, A first and B last. That's easy to get. Once you make this table, you can very easily say it. A first and B last. You can find out this is A first, but B is not last. This is A first, B last. A first, B last. And I don't think there will be, because A in the first place is this much only. So for this third part, if I erase the remaining these things, for the third part is going to be two possibilities, 2 out of 24. That results to give you 1 over 12. Same way you can do either first or second. So first you can see that these are all cases where A is first, and these are the cases where A is second. A is second. A is second. So you can count these are 6, 7, 8, 9, 10, 11, 12. So again 12. So that is 12 over 24. I'm leaving this for you. A just before B for you can do. In this question, it says find the probability that when a hand of 7 cards is drawn from a well shuffled 52 cards, it contains the first one is all kings, second 3 kings, at least 3 kings. So we can figure out that we have altogether 52 cards, out of which 7 cards are drawn, and the case one is all kings. That means out of these 7 cards, right, 4 has to be king and 3 are non-king. And how many kings are there? We have 4 kings and non-king. I mean, the out of 52 cards, if I remove these 4 cards which are king, we are left with how much? 48. So we can say that the favorable outcomes are what? We can say that we need 4 king out of 4. I mean, out of 4 king, we need 4. And then this is multiply, right? Because it's and the remaining, that is remaining 48 cards, from remaining 48 cards, that is non-king, we need 3. And the total possible way of taking out how many cards? From 52 cards, we need 7 cards. So that will be the case for the first part. That is, if I take this as PA as the first part. Then there are some statements that you have to write down, the required probability and all. Now for the second part, what is the case? This time we have again 52 cards, 7 cards are drawn, and this time there are 3 kings. So what we can say here, that say PB, if I take for the second card, we need 3 out of 4 kings. So from 4 kings, we are taking out 3 kings, and the remaining, that means if you have out of 7 cards, if you have taken out 3 cards, we are yet to take out 4 cards, and these 4 cards will be what? From the Non-king, that means 52 minus 4, that is 48. C, wait, we have taken out 3 cards, so we'll require 4 more cards. So let's understand this again. We need 3 king out of 4 king, and altogether there were 7 cards we have to take out. So since we have taken out 3 cards, 4 more has to be taken out from non-king. Well, the total possible way remains same. From 52 cards, we have to take out 7 cards. Now the next case is what? The last case is at least 3 kings, right? So at least 3 kings means what? At least 3 kings means 1 king. Uh, no, at least means 3 or more than 3. So it has to be 3 king or 4 king. So I can see that one more time. At least think 3 kings. We know that how many kings are there? There are 4 kings, right? So at least 3 kings stands for either we have 3 kings or more than 3 kings are 4 kings, cannot be 5 king and all. So we can say that we can obtain this PC, so the third part, at least 3 king, as we can say that probability of getting 3 king and 4 king, and we have calculated the probability of taking out 3 and probability of 4. So you can see that from here, if I mark this equation 1 and 2, so if you add 1 and 2, you will get the required answer for the third part.